So we're going to use our compass and construct a midpoint. So in order to have a midpoint, you first need to have a line segment. So I don't want to draw mine too straight. I'll make it a little slanted like that. And on that line segment, you need both endpoints. I'm going to name my endpoints just so I can refer to them so it's a little bit easy to follow along. So then you need your compass. And the key to using a midpoint, you know the midpoint's going to be in the middle. So we're going to use our compass to find the middle. In order to do that, you need to stretch your compass further than that. So you're going to stretch your compass more than halfway, however far you think halfway is. I like to go about what looks like 3/4 of the way, like 75% of the way. It just needs to be more than halfway. And we're going to draw half a circle. You're going to draw half a circle, just like that. About half a circle. So here's the key. We're going to move your compass to the other point, but you cannot adjust your compass. It needs to keep that exact same distance. So without adjusting your compass at all, you got to move it over to the other point, the other end point. And we're going to draw another half of a circle. So we've got two almost half circles. Now, when I see this, it reminds me of two things. It either number one, it reminds me of a football. That's the first thing. The shape looks like a football. So sometimes I call this the football construction. Football construction from midpoint. So if this was a football, the main thing that's missing from it would be the laces going down the middle. So that's the next step of your construction. You gotta draw all the way from the top X where those two half circles intersected to the bottom X. So where you drew in those laces right there, that line that connects the top of the football to the bottom of the football, that intersection right there is the midpoint. So I'm going to label it M. Since that's the midpoint, that means the left side of this from A to M and the right side of it from M to B are the same length. If you wanted to, you could pull out a ruler and measure it. Or you could take your compass and check it. That length from A to M right there is the same right there from M to B. Same length. Since they're the same length, there's actually a geometry marking that we're going to use here. Since they are the same length, we're going to put these little, they're just called tick marks. So you're going to use these little tick marks to show that the two sides are equal, the two sides are congruent. So there's also a midpoint formula. You probably recognize it from Algebra 1. It's the midpoint, just like we just did with the construction, but now we're going to find it if you know the coordinates. So it's a segment that splits it into a 1-to-1 ratio. That means you got the same length on the one side as you do on the other side. Same length on both sides. So your midpoint formula is x1 plus x2 over 2. That'll give you the x coordinate. That gives you the x coordinate. And y1 plus y2 over 2 gives you the y coordinate. And it's the midpoint, so you're going to write your coordinates in the parentheses separated by a comma, just like that. So, like we mentioned on the last page, a 1-to-1 ratio means midpoint. So we're going to do an example. It says 1-to-1 ratio. That means we're going to find the midpoint. So we're going to use the midpoint formula we just wrote down. So just like with distance formula, I like to label my coordinates and write the formula. So this is xy. This is xy. These would be the 1s. This would be the 2s. And I'm going to write out the formula. x1 plus x2 over 2. y1 plus y2 over 2. And plug in the points that we labeled. So that's -1 plus 4. Whoops, over 2. I was thinking about the answer. y1, -8. y2, -3. So it's plus -3. Since they're both negative, when we combine them, you're just going to add them and keep the negative sign. So -1 plus 4 is 3. That's where I got the 3 before. Over 2. And then -8 and a -3 makes -11 over 2. That's your midpoint. If you were able to divide that, you could. If you wanted to, you can change that to a mixed number or a decimal, like 1.5 or 1.5, and then that'll be -5.5, 5.5. Either way is fine. So this question asks you to go kind of backwards because it tells you point S and it tells you the midpoint. So the best way to go about this question, I like to think of it graphically. So since I have the ability to, I'm just going to copy a graph in here. You can just make a quick sketch though. You'll still get the point across. The better your sketch, the better it'll be. So if you can get the mental picture of this, or a physical picture by actually drawing it, it'll make a lot more sense. So here's S at 7. 1, 2, 3, 4. 7, 4. There's S. And the midpoint T is at -2, -5. That's T. So if T is the midpoint, that means whatever it takes to get from S to T, it would do that one more time to get down to the other endpoint. So that means R is going to be somewhere over there, actually lower down probably. Somewhere down there is going to be R. It might even be off our graph. That's okay. We can count it out. So to get from S to T, I think of it kind of like a slope. To get from S to T, or like a vector, better yet. To get from S to T, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 down. So if you had that as a vector, that vector would be -9, -9. X first, and then the Y. So that's what we're going to do. We got to do that vector one more time to get from T down to R over here somewhere. So if we're currently at -2, -5, and we're going 9 to the left and 9 down, we're at -2, we're going 9 to the left. Where are we going to end up at? -11. We're at -5, we're going down 9 more, -14. That's where R is going to end up. You can do all of this without the graph. It's the exact same concept. You can do it without the graph, but I think it makes a lot more sense once you've seen it once. So to do it without graphing it, you can still accomplish it, or you can pull out a graph every time and kind of count it out just like we did. But we're going from S to the midpoint. So you have to look to get from 7 to 4. From 7 to -2. I don't know why I said 4. From 7 to -2. What do you have to do mathematically to get from 7 to -2? You had to subtract 9. So then you're going to subtract 9 one more time. You get -11, like we said a minute ago. And then same thing with your y coordinates. To get from 4 to -5, you have to, 4 to -5, you got to subtract 9 again. So you do that again. -5 minus 9, that's -14. Same answer we said when we did it graphically. It's the same idea. You're just looking at how you got from endpoint to midpoint, from the endpoint to the midpoint, and then you got to do it again. Or you can graph it out. You can see it visually. So here we've got a brand new problem, just like the last example. We changed the numbers around a little bit. Now, we're going from the endpoint to the midpoint. That means we're going from 2 to 4. What do you need to do to go from 2 to 4? Mathematically, +2. We're only looking to add, subtract, so we're just going to add 2. We're going to do the same thing for the y coordinates. To go from 8, from the endpoint to the midpoint, 9. To get from 8 to 9, what do we have to add or subtract? +1. Whatever you did right there, +2, that was for our x's. So you're going to add 2 to your x. The +1 was for your y's, so you're going to add 1 to your y. So that means the other endpoint, which will be r, is 4 + 2, 6, and 9 + 1, 10. They're pretty easy if you break them down like that.